This conference will now be recorded.
So till now, as part of Q learning, what steps you have learned? 1 to 7 steps. Step 1, environmental, knowledge matrix, and then learning parameter. So finally, finding the possible actions and selecting one of the possible actions. And after that, function for the updation of knowledge, that means Q. And after that, finding the agent. These are the steps. But once it got trained, how your agent will make use of the trained knowledge. This is what the pending part in us. So use trained Q and take decisions to perform actions. So all of you put the heading for this. This is step number 8. Okay. So first take the code, then I will explain step by step. So this is the code part of it. One of you take this code first.
This conference will now be recorded.
So gamma. So function for available actions, next possible actions. The sample next action is the function for to select one of the possible action. Yesterday we took explanation about the update function to update the Q matrix. So in this entire process, where is your Q learning equation? The last step. Observe the formula. Reward of current state comma action plus learning parameter into the max value. Okay. But Bellman equation MDP, the formulas are again different. So after completion of this Q learning, we go for other different algorithms. Now we are going to try it. In the train, finally, you have 4 steps. Taking one current state randomly. That means initial state. From that initial state, possible actions. From those possible actions, select one action. And then update. Whatever the previously have defined 4 functions, you are keeping step by step. Okay. This is what actually the train. But here unnecessarily I have given 10,000 iterations. But in fact, 10,000 iterations are not required. But how to tune the number of iterations, or properly correct giving number of iterations, how to select them. Okay, that explanation in next class I will give you. Please come fast. Yes, I am trying. Just for every 1,000 iterations, we are monitoring this. Is training completed or not, just for our confirmation message. It's done. Now the latest Q values after trial. Think that actual required number of iterations are 250, but we have performed 10,000 iterations. Still, no change in the values. Once training completed, there is no improvement or no change in the Q matrix. Got it? Yesterday, same values you have found out. But here max value 500. In another case, the max value might be 1000. So I want to leverage this max value to 100. So for the purpose, the technique is Q divided by max of the Q into 100. Now the max values 100. You can restore this into your original Q. Q equals. Now the latest values of the Q. These are the things. Okay. All of you take these two lines first. Don't take output flows. Take only the statements. Ready? Yeah. Now start from this step by step. What will happen? Just verify. Current state I am giving as number 0 first initial. Okay. Here state is a root. This is just a path, the path of the steps. How from the 0, how it will reach number 5. Our goal state is number 5. Initially making as a list. The list is having initially the current state value. Now check the values of these states. Check the values of the steps. Just 0. But what is expected? 0, 4, 5. That is what I expect. So that activity will happen within the loop. Observe your loop now. If current state not equal to 5, then only I am performing these operations. That means if current state is 5, no need to perform anything. Understood? If you are already in 5, if you ask to go to the 5, it won't go anywhere. It will stay at 5. Understood this part? That's why you are performing some operation if my current state is not equal to 5. If current state is 5, no need to do anything. That's why that is the initial condition. So within the loop, there are 4 statements. So what each statement will do, try to understand. Observe these ones are already now. You have trained Q. Once again, check the values of the trained Q. Okay, these are the trained Q values. I'm taking current state, all possible actions. Observe this here. But what is the current state? 0. If it is 0, but all the actions available I am going to take. Not actions, the Q values for those actions. Not rewards, the Q values for those actions. That means what are the values? 0 means, right? Now check it. Is a matrix, right? What you need to take? You need to take max values, not max value, max values index number. What is the index number now? 4. 4 should be taken. For that purpose, for the same thing, we are taking this. Just observe this. Sorry. The same thing, we are applying max value. What is the expected answer? 80. We did not apply. Where? We applied only max. The max value will be written. But max is not required for you. We required its index. We are comparing this condition. At which element it is true? Fourth index it is true. Remaining all the things false. Observe here. NP dot. Okay. What happened? In the 0 row, in the fourth column index, the given value is true. Where you are interested about row index or column index? Column index. Column index position. Position is 2. That means index number. Take it now. Got the point? This is what happening in the first line. The max step index you are taking. Understood or no? Why you did not convert into single value? Because if you look at this one, observe this number, look at number 3. There are 2 max values. So that 2 max indexes you will get. That's why you did not convert that into single value. You are keeping still it as a array. Because you can have one single max index or multiple max indexes. Got the point? This is what the first line is doing. In the next step, what is there? Index numbers of max values of the queue. Got it? Come on, all of you tag it as number 1. Give a heading like this. Use queue. Point 1. Use queue. Point 1. For that step by step I will write. Current state. Initially I am giving 0. Steps equals to. Then the current state. What is the initial output? Same as 0. Now use queue point 1. Queue of current underscore state, comma, column indexes you are not giving. If you skip the column indexes, all columns will be taken. What is the output for this? What is the output for this? 0, 0, 0, 0. 80. Understood. After that you applied what? NP dot max. Same thing you are repeating. Current state. What is the expected answer for this? 80. Understood. After that, you are applying a condition. Q of current state equals to np dot max of Q of current state. What is the expected answer? False, 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 true, false. Understood. But at which the given condition is true, you want that index number. That's why for this you apply np dot where of select. Now what you will get? You will get which is an umpire. Pardon? 0 row. We are taking directly the column. Now you are getting index number. Next it will take the action directly. If you keep your agent into 0, directly it will go to number 4 only without any second part. Got it? Come on, take up to this one. This is 0.1 in that function. Yes, we are double equal to. So say double equal to. You are comparing, right? Update, sir. All of you understood this step? Suppose if my current action is 3, current state is 3, there are 2 80s, 2 max values are there. What are those? 4th and 1. Of course, vacancy 1, 4, 2, but for 2, less value. Once again, check it. Look at 3. There are 3 non-zero values. Index 1, index 2, index 4. But max value is for 1 and 4. At the time you will get here 1, 4. What is the meaning of it? If max indexes are 2, 1, 4, anyone is okay. Understand? No need to worry like whether it will choose 1 or it will choose 4. Randomly it can take anything because distance is same. Like that. Okay, I'm testing with number 3, current state 3. No change in the queue. But this time expected answer 1 and 4. Correct? That means any one action is working. Understood this? Now come to the second line. If I have one max index, if I have multiple max indexes. If I have multiple max indexes, what you are doing? Randomly you are selecting one action. Understood? If I have only one, directly taking that action. Understood or not? Come on, for this if condition, put use q point 2. Observe this value. I'm keeping all these things into next step index. My value is not. Still 1 4. Check what is happening. Next step index of shape is a single dimension or double dimension. The result single dimension. So that what you will get 2 comma. Understood this? Where are the required number of elements? If it is single dimension, first element is filled, second element is blank. I'm taking the first element, that means 0. Check it now. Directly 2. If it is greater than 1, that means more than one element is there. That means more than one best action is there. If that is my condition. Understood? We have 1 4. Among 1 4, it has to select anyone. For that, lp dot random dot size of next step. How many things you want? Size equals to. That means among given list, among given multiple values, one value will be selected. Right? You just check it now. What will be printed? Select. But 4 is an array. I need a number. Just it. Okay. When you run the second time, it has selected number 1. Once again, I am running this. Once again, I run it. Now it is taking 4. Understood? Okay. Now you just observe. I am repeating the same function. Suppose if the given condition is false. Directly, I'm taking int of next step. What is my current state? Current state 3. If it is 3, then what are the best policies? 1 4. Among 1 4, it has selected number 1. For example, I'm keeping my current state as 0. In this case, what is the best policy? Number 4 only. Only 4. Now I have only single value. Directly it returns that 4 only. If I have multiple, if I have single. Understood the second step? Okay. Right. Use 2.1. 2.2. If max indexes are 2 or more than that, select one action random. If max index is 1, select that action. That is what your second line. Understood this? Come back to this code. Suppose if my action is my current state is 0, what action selected, sir? What next action selected? 4 select. If my current state is 3, what next action will be selected? Either 1 or 4. Okay. Whatever the action it has selected. Previously we have an empty list. Understood? Now we are appending the selected action to that empty list. Got it. You check it now. What are the steps now? What is the value in the steps? 0. My current state is 0 now. What should be appended to this? 4 should be appended to this. Understood? For example, here instead of printing, I am saying next step index equals next step index equals invalid syntax on bracket extra. Here also on bracket extra because print we removed. Now steps dot append next step index. Once again. Sir, whenever you are checking a value, print is not mandatory. If you give the object name, it will give you the output of that object. Say issue sum of memory issue. So previously steps is having only 0. Now what is that appended? 4 is appended. Got the point. If I give 3, my current action is my current state is 3. Then steps initially having only 3. Now what will be appended? Either 1 or 4 will be appended. Got the point? That's okay. Label it as use 2.3. Steps dot up and down. Next step. What is the variable name you have kept here? Same. Next step relax. Selected action will be appended to steps. That means path. So after completion of this, what is your output? Previously, my current state 0. Now what is appended? 4 is up. Got it? Take the output also. Completed, sir. Last step you just observe. Sir, I am in 0. Hello, hero, sir. Please listen to here. I am in 0. What is my next action now according to this? If I perform, what is my current state now? My current state should be 4, right? As a last step, you are doing that. You are keeping that 4 into current state. You are keeping that 4 into current state. Previous current state 0. Now latest current state 4. Got it? Take this. Use 2.4. Next selected action will become current. Right now current state equals to next step. In this case, current state will become 4. So here till now, one iteration complete. Understood? What has to be done, sir? Now, what is your current state in the second iteration now? 4. Now, what the steps is having? Hmm? Steps equal to current state. That means the previous steps will be overridden or not? Overridden or not? But it should not be overridden. For that, what the change required, you just observe in the code. Actually, we are not going out of the loop. In the next iteration, where we are coming? In the loop only we will be there. We are not going out of the loop. So still steps is having 0 and 4 only. Understood the point, sir? 0 and 4 only. Are you understanding my point? Then what will happen here? What is the current state value now? Taking 4. From the 4, max indexes will be selected. One of max index will be selected again. And after that is appended to previous list steps. Already the steps is having 0, 4. Now what will be added? 5 will be appended for that. Now what exactly the path now? 0, 4, 5. After that, what is our current state? 5. Again check the condition. 5 not equals to 5. Condition false. Come out of the loop. So this loop runs till it achieved goal state. Your goal state is number 5. Understood this point? Okay, try to do the same thing with the current state too, sir. You tell me what happened. Current state 2. Here what is selected? 3 selected. Here what will be selected? Index number 3 selected. 3 is a single value or multiple values? Previously this is an array. Now it will become a single value 3. Previously steps is having what? Steps is having what? Only 2. Only 2. Now what is appended? 3 appended. Now the current state become 3. Again check the condition. True or false? True. Enter into the loop. Enter into the loop. If it is 3, what are the max indexes? 1, 4. From the 1, 4, anyone is selected. Think that number 4 selected. Again you are appending that 4 to steps. Now what is there in the list? 2, 3, 4. Now what is our current state? 4. Again check the condition. Condition still true. Again enter into the loop. What is selected? 5 is a single value converted into single value. Now steps start up and down. That 5, 2, 3, 4, 5. Now current state 5. Check the condition. False. Come out of the loop. And then you are printing selected. What is your path now? 2, 3, 4. Did you understand this? Just check it now. I'm coming from 0. What is the best path? 0, 4, 5. Check it. Correct or no? Now keeping into 1. Tell me the path. 1, 5. That's it. Keep into 2. Expected path. 2 possible ways are there. 2, 3, 4, 5. 2, 3, 1, 5. Anything is okay? 2, 3, 4, 5 selected. Maybe other time 2, 3, 1, 5 is selected. Keeping you into 3, 3, 4, 5 or 3, 1, 5. 3, 1, 5 selected. Both are okay. Next, keeping you into number 5. Sorry, 4. 4, 5 is the best path. Keeping you into number 5. It won't go anywhere. It is there in the 5. That's why it stay there in the 5. Because 5 is already a goal state. Understood. Check all the possible ways. Just one step. Sorry. one state. For that I am giving selected path. For this selected path, I am giving the value steps. Compare the things. And where the mistake. Here your current state is equal to, because always we are fixing as 5. Compare all the values. Correct addition or not? This is called dynamic programming. Whatever the programming we are doing, that is rule-based programming. So the same thing in the rule-based program. What is the style? What is the style? The style is like this. If room is 0, then path should be 0, 4, 5. This is what rule based. Else if room is equals to 1, then what is the path? That's a path. Path equals to 1, 5. No, 1, 5, that's it. L if room is equal to 2, then path equals to 2, 3, 1, 5. We have to fix it. Again, L if room is equal to 3, path equal to 3, 4, 5. L if room is equal to 4, path equal to 4, 5. L if else remaining only one thing, right? Room equal to else path equal to 5. This is called rule based program. All our applications till now, whatever we have seen, those are rule based program. Whatever the program with the reinforcement learning, that with the Q learning equation you have seen, that is called dynamic program. Now you tell me the difference between tell me your answer. What is your understanding from this? First, don't say answer, think for 1 minute. Think for 1 minute and then tell me answer. This is called rule based. Previous program is called dynamic based. All of you start thinking. All our old artificial intelligence based applications are rule based. Do you know when was the first robo? First robo in the world? 1953. But those robots are rule based robots. That means into those chips, this rule based programming is embedded into that. Understood? But nowadays, latest robots are AI based applications are reinforcement based. It means Q learning based. Now, so forget about that. What difference you have? In rule based, you are giving instruction set. You are giving instruction set means, first of all, you should have intelligence about that environment. This is the whatever the game I have given you. That is a very, very simple game. LKZ game or UKZ game. That's it. That's why your brain worked out to decide which is the optimized path. I am giving you 700 rooms. Understand the point, sir? 700 rooms. Lot of rooms are interconnected, lot of rooms are not connected. The two different clustered rooms are there. One cluster to another cluster connectivity. From one cluster to another cluster no connectivity. A complex environment. Does your brain support to decide which is the best path? If you want to commit for the rule-based programming, means first of all the developer should have intelligence about that. But here I am a layman. I don't have any intelligence. Everything my agent has learnt it. Self-learning or somebody is giving training? Self-learning. Of course, we are not giving training. We are plugging with Q-learning equation to the agent. Automatically, the Q-learning is feeding the best knowledge into the agent. Understand the point, sir? What the difference between rule-based programming and dynamic programming? So recently, one of discussion from one of the candidate is in an interview. What is dynamic programming? Means the answer is Python is dynamic program because we say that a equal to 100. We did not give any variable type like int or long. This is called dynamic programming, he said. In fact, that is not. This is called a dynamic variable declaration, dynamic data type declaration. Dynamic programming means automatically the expected knowledge has to be learnt by the agent with help of some algorithm. In fact, we say that we train agent, we train agent. In fact, we are not giving training to the agent. We are plugging the brain to the agent. Understand? There is a Q, there is a E. E means environment. There is a Q, means knowledge. Understand the point, sir? That means you are creating action space, state space, reward space, and then creating a knowledge matrix. After that, plug in with brain. The brain is Q learning. Understood? Then automatically knowledge is grasped by the agent. All of you understood this? Because if it is simple environment, you can go for rule based. If it is simple environment, you can go for rule based. But complex environment, you cannot do. Understood this? What was your last note, sir? Last one. 3.3 or 3.4? Completed? Okay, sir. Till now, what are the things you have completed? The practice. I think till now 8 sessions of reinforcement. Can you repeat the steps? Anusha, please go to mute. Okay, Anusha. What are the steps? What are the end-to-end process? First, environment matrix. Then knowledge, learning parameter. Next, finding actions, possible next actions. Next, select one possible next action. Next, a function for update. Actually, in the update, the learning process will happen. With the help of update function, the learning process. Because the update function is updating the Q matrix. Final, next, fine, next. How your agent can use knowledge matrix. Now, next step. You have to test it or not? Testing. But today we did a test. This test is manual, but industry needs automation. Understood the point, sir? So those things you will be learning in the climax of this reinforcement learning. With the help of program, how to test it. Now you test it manually. First you are keeping 0. Expected is 0.45. You know that. And then you are testing it manually from each state. Understand? But this has to be tested in an automated way. So in the climax, I will show you the program, the Python related program, how to do it automated test for our agent behavior. Got it? Testing is also completed. Then What will be the next step again? Deployment. What you have to deploy? You have to deploy environments. Because without environment with knowledge, what you do? Understand the point, sir? Without environment with knowledge, what you do? That means environment, trained knowledge, and the agent. Agent means here. No need to give all the beginning 7 steps. Only have to give the last step, 8th step. Because agent has to use the trained Q knowledge matrix. So these 3 things you need to deploy. And one more thing, when retraining is required, when rule changed, when our rules changed, again we need to retrain the agent. Understood? So depends on the organization, depends on the business use case. For some businesses, rules will be changed yearly once or yearly twice. But a lot of businesses, very frequently rules will be changed. Maybe in some complex environments, rules will be changed day to day also. Understood the point? So when our rule got changed, again retraining of the agent is required. Okay. So in the next class, I will take the session about the statistics, because for the past 3 days onwards, 3 to 4 days onwards, statistics class is pending. So tomorrow class completely I dedicate for this statistics basics, especially the linear algebra, which is related with predictive models. Okay. Yeah. 1 minute. 1 minute.